Here we are discussing an important question from the chapter complex numbers. Question is, represent the complex number 2 plus 6 root 3i upon 5 plus root 3i in the polar form. Here this is Cartesian form of the complex number. Let us suppose z is the complex number z, which is equal to 2 plus 6 into root 3i upon 5 plus root 3i. First of all, we will rationalize this complex number by multiplying numerator and denominator both by the conjugate of this denominator. So, conjugate of denominator will be 5 minus root 3i. So, multiplying numerator and denominator with 5 minus root 3i. So, this is 2 plus 6 into root 3i upon 5 plus root 3i into 5 minus root 3i upon 5 minus root 3i. Let us simplify it. These two numerators will be multiplied together. So 2 into 5 minus root 3i plus 6 root 3i into 5 minus root 3i. Similarly, in denominator also, this is 5 plus root 3i, 5 minus root 3i. This is in the form of a plus b into a minus b, which is equal to a square means 5 square minus b square means root 3i whole square. And this is equal to, we have 2 into 5 minus root 3i. So this is 10 minus 2 into root 3i plus 30 into root 3i and 6 root 3i minus into minus root 3i. I square is minus 1, so this minus becomes plus, and 6 into 3 is 18. And in denominator, 5 square is 25, this I square is minus 1, so it becomes plus 3. Root 3 square is 3. And let us simplify it. Here 10 plus 18, this is 28, and 30 minus 2 is 28 plus 28 into root 3i divided by 28. Here 28 will be common in the numerator. So 28 into 1 plus root 3i upon 28. This 28 will be cancelled out. So this is equal to 1 plus root 3i. This is the Cartesian form of this given complex number. As you know, the standard form of the complex number z is equal to x plus iy. Here in this case, x is equal to 1 and y is equal to root 3. So the corresponding point corresponding to this complex number, corresponding point 1 root 3, this Cartesian coordinates will lie in first quadrant because x as well as y, both the coordinates are positive. Okay. Now we have to convert this, we have to represent this complex number in the polar form, and we know that polar form of the complex number, let us say z, can be written as r into cos of theta plus I sine of theta. Okay. So now we will compare these two relations, relation number 1 and relation number 2. Here we will have to find out value of r and theta, and by putting the values of r and theta, we will get the complex number in polar form. Correct? So comparing 1 and 2, comparing relation 1 and 2. Here real part is r cos theta and here this is 1, and imaginary part is r sine theta is equal to root 3. Therefore, now squaring and adding these two relations, so in left hand side r square is common, r square into cos square theta plus sin square theta is equal to 1 square plus root 3 square, that is 1 plus 3, which is equal to 4. Or here cos square theta plus sin square theta is equal to 1, so we are getting r square is equal to 4, and therefore r is equal to 2. So here we are getting the value of r is equal to 2. Now we have to find out value of theta. Okay, so dividing these two relations, we will get now r sin theta upon r cos theta, this is equal to root 3 by 1. R is cancelled out, and we are getting tan theta is equal to root 3, and root 3 is tan pi by 3. So as this point is lying on the first quadrant, we have to take theta is equal to pi by 3. Therefore, we are getting theta is equal to pi by 3 by comparing tan theta is equal to tan pi by 3. So here we are getting value of r as well as value of theta. So we can write the given complex number in its polar form. Therefore, in polar form, complex number z is equal to r cos theta plus I sin theta. R is 2, cos of theta is pi by 3 plus I sin of pi by 3. So this is the required answer. This is the polar form of this given complex number. Correct? Hope you have understood it. Very interesting. Okay, so remain in touch with these videos. We have to see some more important questions, and please share this video with your friends also. Wish you all the best.